Hello, Honors Algebra students. Mr. Laurence here, and this video is gonna kind of be a review of something we did a little while ago, but we didn't do much with. I've been spending so much time on writing these functions and then the geometric and arithmetic sequences. We really need to understand what a function is. The definition that I'd really like to use is a function is a rule that assigns each input, or x value, to a single output, an f of x, or in some cases, a y. Now, I'm using y because when we go to graph, certain things won't be a function, they'll only be a relation, okay, if they don't follow this rule. And you're going to see on some graphs there's going to be an x-axis and a y-axis. But on other graphs you're going to see an x and an f of x, okay? When it's an f of x, you know it's a function. All right, but let's go down and see if we can figure out what this is talking about, okay? Here I've given you two tables, like we've made for writing our functions. And I'm showing you that -2 is going to 4. When the input is 1, the output is 1. When the input is 0, the output is, oops, I have a mistake there. That should be a -1. Sorry about that. Okay. 0 going to 0, +1 going to 1, and 2 going to 4. Is this a function or is it only a relation? Well, look at each input, okay? Each input. Does it go to more than one output? If it does, then it's not a function, it's only a relation. I've got -2 only going to 4. I've got -1 only going to +1. I've got 0 going to 0. I've got 1 going to +1. And I've got 2 going to 4. So no member of the input goes to more than one output. This is a function. You might remember from a video quite a while ago now, a couple weeks, I said inputs are like people and outputs are restaurants, okay? Is it possible for Bob to go to McDonald's and Burger King at the same time? No, it's not. That's not a function, okay? That would only be a relation. Is it possible for Bob, one of the inputs, and Sally, another input, to go to the same restaurant, like Red Lobster? Sure it is. They both can go to the same restaurant. They don't even have to go together. They could be there at the same time, coincidentally. So that would be a function. So I think of the inputs, the x values, as people, and the outputs as restaurants or destinations. Now, you can't use that argument on the park. You have to use this definition. But to help you with the understanding what the definition is trying to say, we can use that analogy to understand it. Okay, so let's look at B. So here I have 4 going to -2. But over here I have a 4 going to a +2. This is not a function. This is like Bob going to 2 different places at the same time. This we call a relation. Okay, that we call a relation. All right, let's look at some more examples. Now, sometimes functions or relations are expressed in kind of these tables here, and I've got these funny words, domain and range, and I think I defined them for you once, but we haven't used them, so I'll redefine them for you. Domain is just your input or your x values. Range is your y values or your f of x values, and therefore it is output. All right, so sorry. Okay, so let's check this out here. In this first one, I have 11 going only to 46 in this mapping. 7 going only 30. 3 is trying to go to 2 different places at the same time. This is a relation. This is a relation. Okay? Now, on this one over here, I've got this map where 1's going to 14, 2's going to 13, 3's going to 12, and 4 is going to 14. Is that okay? Can these two people go to the same restaurant? Sure they can. So this is a function. Okay? Now, functions can also be expressed as a graph. Okay? Now, graphs are easiest way to tell. I love to use something called the vertical line test, and I've talked to you about this before. The vertical line test, I'm going to make this vertical line. I'm going to make it, oops, it's not vertical anymore. Let me get it back to being vertical. Okay, and I'm going to make it a lot thinner. All right, hold on a second. There we go. Okay, so first I'm going to visually look, and I'm going to see my x values on a graph would be the horizontal values, right? The independent variable, x is the independent variable, and then this is using y, so I'll put y up there, okay? I'm not going to put f of x because I'm not positive it's a function yet. I know that this line is going to go forever, this linear graph. Will there be any x value that will have two y values, two outputs? Well, let's see. This here is x is 1. When x is 1, y is 4, I think. Yeah. Is it any other number? Can you get any other number out? No. This is probably a function. But you know what I'll do is I'll bring this vertical line over here. And I'll see, is there any place where this vertical line is going to intersect that blue line more than once? And of course, no, they can only intersect at one point. This is a function. All right, let's go over to, I should label that here. Function, function, function. Sound like conjunction, junction, right? Okay, so this one here, this quadratic, makes a parabola, right? We've talked about parabolas, and remember, it would go forever. The graphing calculators don't show that it goes forever, but we know it does. Is there any x value that will have more than one y value? No, there isn't. And I can prove that using my vertical line. There's no place I can put this vertical line that it will intersect the blue segment more than once. So this is also a function. All right, so I will give it the function stamp. There we go. All right, let's slide on down here, and I might need to change the color of this. I think I'm going to change the color. All right, and let's see. Let me change it. Ooh, okay, there we go. I'm looking at this one visually, and I'm wondering, you know, it says here when x is 2, I'm getting this 1.41 number. But I also think that when x is 2, I'm going to get a number down here. You see how I'm going to get two answers? X is the people, the y values are the restaurants, and so in this case, the x value is going to more than one place. The person is going to two restaurants at the same time. And look at this green vertical line. It's intersecting this sideways parabola all over the place. It's intersecting at more than one value everywhere except for right there. Here it's except two y values, two y values, two y values, two y values, two y values. So lots of the x values are going to more than one y value. This is only a relation. This is a relation, not a function. It's a relation. Okay, this one here, this is actually an exponential graph. I don't know if you know that. And I'll put f of x this time. It doesn't look to me like any x values are going to be repeated. Now, some of you might be wondering about this area right here. We'll talk more about this in class. These are not 0. They're just pretty darn close to 0, and they're getting closer and closer and closer. They aren't ever going to get to 0. There's actually something we call an asymptote here. We've talked about asymptotes before. And it's like a magical force field or barrier that the graph will not cross. So, anyway, let's do the vertical line test just to make sure. And no, it looks like it's only going to hit that blue curve in one place at any one given x value, any one input. This is a function. Oops. All right. Uh-oh. Danger, Will Robinson. Okay, so this is a function. Okay, I got two more to look at here, and then we're going to end this video. All right. Let me just turn the shade off. I've got these two linear equations. Okay. The best thing I would do would be to make a table. And these are actually really easy. Really easy. I don't need to put in a whole lot of values. I can actually just put in 2 or 3. Let's go with 0, 1, 2, 3 as my input. I could have picked anything. And how do I know what y is? Well, look at the equation. It says y equals 3. And this one says y equals 3. And it says y equals 3. Hey, what's y? It's 3. That means all these x's are going to the same y. That's like 1, 2, 3, 4 different people going to the same restaurant. This is a function. This is a function. Okay, this one, however, when I make this table, okay, I can't put 0 in for x. Why not? Because x equals 2. I can't put 1 in for x. Why not? Because x equals 2. I can't put 3 in because x equals 2. Can't put 4 in because why? X equals 2. What do I put in for y? Anything I want. 7, 19, 25, and 300. 3,000. The only restriction is that x must be 2. Is this a function? Well, I've got the same person going to 1, 2, 3, 4 different restaurants at the same time. Not possible. This is a relation. All right, that is your video for the weekend. Mr. Laurence signing off. Have a good night, everybody.